All right, it's recording. Let's do a bit of recap. Let's see what you remember so far, because so far the last few exercises, just to make sure you remember your derivative rules. So, one of the derivative rules that we know is if you have f of x is equal to e to the x, the derivative is equal to what? Can I please have Joe?
E to the x.
E to the x as it is as well. What if I had log base e of x? The derivative of that is what, Samuel?
That's 1 on x.
1 on x. Very good. Let's go Tara. What if f of x was sine of x? It'll be positive cosine of x. And then if it's cosine of x, that would be what? Let's go with Rango. Negative sine of x. That is correct. And then if I go to tan of x, the derivative of that is equal to what? Let's go with Mia. Oh, you were aware that lesson. Let's go with Serena. 1 on cos of x all squared, which is also known as the second squared of x, because second of x is 1 on cos x. Those are your transcendental functions, and what that just basically means is your solutions are not a polynomial solution. So then what if you had a polynomial? For example, f of x is x to the power of n. What is the derivative if you have ax to the power of n? So n could be power of whatever it is. It's a rational number. What is the derivative of ax to the power of n? Let's go with Ryan.
Nax to the power of n.
Beautiful. This is technically also known as your power rule. So n times a times x to the power of n minus 1. This is known as your power rule. And then along the side, we have a few other techniques. One of which, our last lesson, which is your bread and butter of the course, it's called chain rule. What is the chain rule again? Can I please have Noah is here? Yes, Noah?
dy dx
Delta y delta x.
equal to dy du over du dy
Ooh.
du dx.
Very good. This is the one that's easy to remember, but you could have in your exam or your formula sheet, it might be something like if you had a composite function, so let's say h of x is equal to f of g of x, then the derivative of h of x equals to what? What's the notation? Anyone who wants to have a go? So this is chain rule again, but this time I'm instead of calling it y and u, I'm using function notation. Rango?
G of x, then the derivative of g of x.
Yes, that is correct. That's your delta u delta x.
The derivative of f of x with g of x in it.
Beautiful. This is like, if it helps you, try to think of this as your u. So then if you want to find delta y delta u, which is this first one, delta y delta u is the function with u in it. So that's why that's your derivative with u in it. Whereas this one is u. So if you want to find delta u delta x, let's find the derivative of g of x. Hence, it's there. So in a way, this is representing delta u delta x. And this is representing delta y delta u. Okay? Just to help you, because that will likely be in the formula sheet of some form. They don't give you delta y delta x. That's an informal way of explaining it. And then today, we're adding on 2 extra techniques, which is product rule versus quotient rule. Now, I believe in year 11, you would have learnt product rule. Hands up if you've learnt product rule in year 11. Oh, no. Quotient rule? Okay. Well, then, for maybe some of us, it's new. Then, okay, in that case, I will start from the beginning. All right. Here's your rule. I've already got it up here. The products rule, product means multiplication. So this means multiplication. instead of having a function within a function, if you have a function times a function, for example, let's say u was sine of x multiplied to the cos of x. So if I said y equals that, and I asked you to find the derivative of this, so that means delta y delta x. You see, we can't derive this where we separate the sine and the cosine. We can't say derivative of sine is cos and derivative of cos is negative sine. There's a multiplication sign in between them, so that's a problem. We can't expand it either because it's just sine x cos x. So that's where we use product rule. So product rule, it is equivalent. If you can see there's a u times a v function, then it is v, which is the original one, times the derivative of the first function, plus u times the derivative of the second function. In other words, it looks like this. So it means if I called this u, I need to find u dash, which is the derivative of sine. And if I called this v, then I need to find the derivative of v. Now, notice in the formula for both of them, I purposely did this that is different to your textbook. I put vu dash first. Might look like an accident, but your textbooks would normally write it as uv dash plus vu dash because it's in order, u before v. The reason why I wrote it as vu dash to help you is because when you're adding, it's commutative, meaning it doesn't matter about the order. But in quotient rule, subtraction does. It does matter if it's vu first or uv first. Okay, so that's why I try to help you remember that product rule, it's vu dash plus uv. And if you remember that way, then you also remember for quotient rule, it's vu dash minus uv dash. So if you remember product, you'll remember quotient in a way. It helps you. Okay? And back in the past, I used to say to students that just remember it as Victoria University first. That's the goal. Yeah, I know. And as soon as you say what, then it helps you remember. It's just one of those things that you question it, and then because you question it, you remember it. So Victoria University first is the option. So VU first before UV. All right. So let's do some examples to utilize the rules. Quotient means division. So if you have a division of functions versus product of functions, these are your two rules. Note in your exams, they will not give you these versions of the rules. They will give you the function notation version of those rules. Okay, so whilst you're doing it, you do need to also familiarize yourself with the function notation version. Let's do an example. Let's have a look at this one. Example 1a. Currently, you've got sine of x multiplied to x squared. So you've got a quadratic and you've got a circular function. Is this likely a product rule or a quotient rule? Which one would I be doing? Product rule, because it's multiplying. So you just need to say, well, which one is the first function? Which one's the second function? Doesn't matter which one. I'm going to let u equal to the first one, which I see is sine of x, and v, which is then x squared. The derivative of each one, so I need to find u dash, I need to find v dash. Derivative of sine, which you guys told me before, derivative of sine is? Cos. So this should be cos of x. Derivative of x squared, which we know, 2x. Now using product rule, VU, remember Victoria University first, VU dash plus UV dash. That gives me V, which is currently, and a way to remember it, you can do a cross, like a little cross like that, and it helps you know which one you're multiplying. It's x squared with the cos of x. So I would then write x squared, which is my V, times u dash, which is cos of x. Maybe I'll take away the brackets to make it easier. Cos of x plus u, which is sine of x, is multiplied to 2x. That gives me x squared cos of x, and I like to write the x's at the front, so I'm going to write 2x sine x. Usually in the exam, this is worth 2 marks. So the first mark is probably applying the correct approach, which is a product rule. The second mark, I encourage you to factorize where you can see. Most times in exams, there is something that you can factorize. In this case, what can you factorize? X. They both have an X. I encourage you to take that next step and write it out as X cos of X plus 2 sin of X. Okay. Sometimes the examiners, which is rarely, but sometimes they might not give you the mark if you don't take that extra step. As you're doing the exam questions, in the next one you might find that there are common factors of e to the x, for example, or 1 on x. Just got to be attentive to it. Let's do the next one. I'm going to give you, let's go 3 minutes, because usually it's about 1 or 2 marks. 1.5 times 2 gives you 3 minutes. Let's pause the video. Here we go. Chain rule, derivative of negative 2x is negative 2 times derivative of the entire function. You got to pretend it's as if it's e to the u. So you would actually get e to the negative 2x there. Hands up if you got the derivative of du dx, or u dash is negative 2 e to the negative 2x. Good. All right. Let's do the second one. Same thing. Find the derivative of the inside. So x squared minus 2x is 2x minus 2. So that's your delta u delta x. Multiply that 2. Now pretend as if you just got cos of something. Derivative of cos is negative sine. So it should be negative sine of whatever's in the bracket. So x squared minus 2x. Is that what we got? Roughly? Yeah, so the derivative of cos of x squared minus 2x. This is the problem. So derivative of u is here. And then derive the function. Cos is sine. And then whatever that is, you replace the u back. Okay? All right. Next step. I would have kept it as it is, and then I just move on to the next step. I say delta y delta x is equal to v times x. So v times x is cos of x squared minus 2x. I'm timesing it to negative 2e to the power of negative 2x plus u times v dash. So you should now have e to the negative 2x times 2x minus 2 times negative sine of x squared minus 2x.
So far so good?
All right. And then from here, I would then try to find any numbers I can factorize. So clearly both of them have an e to the negative 2x. So I would have taken out e negative 2x. I can see that there's a 2 inside the brackets here. So you could probably, oh, but then it's not in the other. Oh no, they also have a 2. That's good. So they both have a 2. I guess you could take out the negative as well, since they both have this negative over here. Negative and a negative there. So maybe I would take out the negative 2, do square brackets. And what does that give me? That gives me cos of x squared minus 2x. The negative 2 is out, so that's sweet. That's perfect. Plus, I've taken that e of x, I've taken the 2, so it should be x minus 1 in the brackets there. And then there'll be sine of x squared minus 2x. Something like that is what I probably would have left. Because this is likely 2 marks, I probably won't do much more than that. And we just left it something like that. The x minus 1?
Yeah.
So this one, I took out 2, so it's x minus 1. And then that 2 and this 2 is out here.
Oh.
I skipped a couple of steps there. Sorry.
Oh, okay, yeah, okay.
Yeah, so that minus 2e to the negative 2x, and you got plus 2 bracket x minus 1 e to the negative 2x. I took that 2 and that 2. But notice there's that negative here as well, so that's why I took out negative 2e to negative 2x. And clearly this would times 1 to get that. And then to get this one, I just needed times, yeah, x minus 1. And that's it. Maybe write it out to, like, instead of my skipping steps, maybe there should be an intermediate step in between. I'm going to move this a bit down. So if we wrote it again, it's cos of x squared minus 2x, negative 2e to negative 2x, plus e to negative 2x times. See that negative there? Let's just attach it with this 2 to make it easier. So if I attach it, it's negative 2 x minus 1 times sine of x squared minus 2x. So from there, you can then see I've got a negative 2. They both have a negative 2, and they both have e to the negative 2x. And that's how I took out negative 2 out here, and then e to the negative 2 out. So what is left over is what's inside the brackets. Okay, now I think that's why at the year 12 exams, usually that's second mark. That's why they want this step, because it kind of separates a bit in an algebra sense, how many students can do that and move forward, or make mistakes as well. So that second mark, I encourage you to factorize it, because I do think they, in some years, if they can't distribute it evenly, they'll take marks off there. Okay. All right, team, let's try question rule. Let's try the next example. Next two examples. Same thing, question rule is the other way, VU first, but it's VU dash minus UV dash all on V squared. So here we go, let's have a look. U is the numerator, so let U equal to x cubed plus 2x. And V is the denominator, so then that would be now x to the power 5 plus 2. Find the derivative. This is nice little power rule, so what's 3x squared plus 2. And this is 5x to the 4, and that's it. Quotient rule says it's VU dash minus this time, so it does matter what the order is. So again, the cross is V times the U dash, U times the V dash. You should have x to the 5 plus 2 multiplied to 3x squared plus 2. Take away U, which is x cubed plus 2x, multiplied to V dash is 5x to the 4. All over V squared. So that's probably how I would write it. No, never expand. Unless if your expansion can simplify better, that's when you expand. What you should do here is see what you can simplify. Well, I can only see this one.
The bottom bit be squared.
Thank you. I did forget that. I can only take out x from here. But if I do, then... yeah, that's about it, really. I probably would have just done it like this. That's probably how I would have done it. So by taking out the x times 5x to the power 4 becomes 5x to the power 5. That's the only thing I would have done. And I lost the, sorry, my bad. I also lost the, no, that's it, yeah. Does that make sense what I did there, or did I skip too much of a step? Yeah, I just took out the x, and that becomes x squared plus 2x. But if you're timesing it, this times this becomes that. And yes, it is minus. So it should be minus there. Okay, so I just took out the x and times it to that. Let's pause the video. Let's give you And this is the it for my lesson, but that's your last example. On the back of the page is some VCAR type examples so that you can see what 3 marks or 2 marks kind of looks like. It is expected that when you do them, eventually it's just one step to find the product rule, and then the second step to get your evaluated value. Okay? Yep. No, because I'm doing all the rules first, and then once you know all the rules, then we go back to theory again. Let's pause. Let's see what you guys got. Should have got VU dash. Let's go V times U. So you would have got 6x times cos of x minus UV dash. So U times V dash. So negative and negative is plus. 3x squared plus 1 times sine of x. And what do they both have in common? Did I do it wrong?
What does this look like, Ryan?
I think that's about it. I can't see what's in common. I probably would have just left it there. Oh no, wait, the question's asking f dash of pi.
That was the worst thing I've ever heard. Even Neil had it. Neil was hating it.
All right, so what's that? You would get cos of pi is -1. Cos sine of pi is 0. So 0 times that just cancels out. And -1 squared is 1. So really you got -6 pi on 1. So what you guys got? Sounds good. There we go.